No, actually, he got it. No, it's in his credit time, but he got it already. But how come I put a whole section? This is not that.
All right, guys, we're finishing up the note sheets from yesterday. So some of the last things we need to talk about is the remainder theorem. So if a polynomial f is divided by x minus k, then the remainder, r, is equal to f of k. So if we plugged a certain value in, a value for x, the remainder is going to be the same thing as if we plugged it into the function. The remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. That is, to evaluate a function for a given value by plugging it in. So if we wanted to evaluate this function here for -2, we can do our synthetic division. We would plug -2 in the cubby, and then plug our coefficients across the top. So 3 would be for our x cubed, +8 would be our x squared, 5 would be our x, and -7 would be the constant term. So we take the coefficients, we don't take the variables, and we bring the first number down. First thing we're going to do is multiply. So -2 times 3 is -6. And we add straight down. 8 plus -6 is going to be 2. -2 times 2 is going to give us -4. 5 plus -4 gives us 1. -2 times 1 is -2. And -7 plus -2 would give us -9. So the remainder in our case is -9. So it's telling us if we evaluated this, f of x, if we took f of -2, we should get a value of -9. And we can verify that by plugging it in. So we could say 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. Now, if we were doing this here, we could type the whole thing in the calculator and let it do it for us. If we work this out by hand, -2 cubed is going to be -8 plus -8 -2 squared is going to be +4. 5 times -2 is -10 minus 7. 3 times -8 is going to be -24. 8 times 4 is 32. And -10 minus 7 is -17. -24 plus 32 is going to be +8. And 8 minus 17 is -9, just like we got from the synthetic division. So that tells us a few things. One, we're able to evaluate f of -2. That if we plug -2 into the function, we'll get a value of -9. It also tells us that this x equals -2 is not a solution, it's not a factor. Because if -2 was a factor, the remainder should be 0. Because if the remainder is 0, it is a solution, meaning it is a factor. Questions on this here? This here, -9, so 2 -9 is a solution. There's a point, and we could check it there. Another important theorem is the factor theorem, which states a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. Just kind of like what we just stated. So if we get 0 as a remainder, it means it's a factor as well as a solution. So if we wanted to show that x minus 2 and x plus 3 are factors of this here, well, all we have to do is show that using synthetic division, we get a remainder of 0. Now with x minus 2, we'd set it equal to 0 and solve for the value of x. So the value we would plug in for x minus 2 is 2. Because 2 minus 2 would give us 0. One of the solutions is possibly going to be, or is actually going to be 2. 2, 7, -4, -27, -18. And if it is a solution, this last number should be 0. And since we are showing that they are solutions, the remainder should be 0 for this here. Now the first thing we'll do is bring the 2 down. Now 2 times 2 is 4. 7 plus 4 is 11. 2 times 11 is 22. Then we add straight down. Negative 4 plus 22 would give us 18. We multiply again. 2 times 18 is 36. Negative 27 plus 36 is positive 9. And lastly, 2 times 9 is 18. And negative 18 plus 18 is indeed 0. So we're able to show that x minus 2 is a factor. We also need to show that x plus 3 is a factor. Do the same thing. And this time we're using negative 3, because if x plus 3 is a factor, its solution is negative 3. Now we could apply to the first one, or we can just keep going with what we have from this here, because if it's a factor of one of the parts, it's a factor of all of them. So we bring down the 2. Negative 3 times positive 2 is negative 6. 11 plus negative 6 is 5. Negative 3 times 5 is negative 15. 18 plus negative 15 is 3. 3 times negative 3 is negative 9. And 9 plus negative 9 is 0. So we're able to show this here that 2 and negative 3 are both factors. And from what we had yesterday, really what we can say from this here, our starting equation, let me write up here, is 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18 is equal to our x minus 2 times x plus 3 times what we have remaining. Now we didn't put the variables back in, so this is our remainder. 3 is our term without x. 5 is our term with x, and 2 is our term with x squared. Almost. Is it in factored form? Because we said those two were factors, so they would multiply together with what we have to get to the end. Questions on this so far? Incidentally, the 2x squared plus 5x plus 3 is factorable. Now we couldn't factor it in the starting form with our x to the fourth. This entire thing here, we could have. It would take some working to try to get all the factors. But it's going to be a lot easier for us to factor now the 2x squared plus 5x plus 3. Since the third term's positive, the signs are the same and match the sign of the middle term. Factors of 2x squared, well, we'd have x and x, 2 and 1. Now the factors of 3, there's only one set, 3 and 1. And it'll actually end up factoring to 2x plus 3 times x plus 1. So this here is it completely factored. So doing this here and given the factors, we can actually find the rest of it and factor it completely. And we did find the remaining factors. Questions on this here? As we see this here, they use synthetic division. We show that x minus 2 is a solution. Same thing for x plus 3. Then we take the result and are able to factor it, telling us that these are the factors. So really, we're breaking it down to a quadratic and solving from there. Questions on anything we've done so far? Well, we can do the same thing with something like this here. Now, this one was kind of nice to us. They told us that one of the solutions, or one of our factors, is 2 minus the square root of 5. Now we can still do synthetic division with this. But especially if we have these two terms, it's going to be nice to have a little more space. A little more space to work with. Bring this up. Now if this is going to be a factor, we know that this last number has to be what? 0. And again, just like with normal synthetic division, we bring the first term down. Now what we're going to do first is we're going to multiply. We have to do 2 minus the square root of 5 by 2. Now normally we did most of this in our head. We did it simply because we're just multiplying numbers normally. Here we're multiplying through the two terms. Same process, except it might be a little bit nice for us to see it. 2 times 2 is going to be 4. 2 times the negative square root of 5 is negative 2 square roots of 5. So our 2 times 2 minus the square root of 5 is 4 minus 2 square roots of 5. And we add straight down. Now the negative 3 and 4 are going to add together because they are like terms. Negative 3 plus 4 is 1. So what we actually have is 1 minus 2 square root of 5. Bless you. But we could have also come over here, 2 times 1 minus, I think that was 2. Yeah, it's 2. It gives us the same thing, it just puts the radical in front. We add negative 3 to it. We get to the same exact spot. Now again, at this point, now we're going to have to multiply again. We're going to have to multiply our 2 minus the square root of 5 by our 1 minus 2 square roots of 5. And again, we can do this by hand. 2 minus the square root of 5 times 1 minus 2. Or we let the calculator do it. 12 minus 5 square roots of 5. Either one will work. Now, if you're going to use a calculator, you're going to have to use the 30xs, the yellow calculator, because the graphing calculator is going to convert everything to a decimal. Questions on this so far? Then what we're going to do, we're going to add straight down. So negative 25 plus 12 is going to be negative 13 minus 5 square roots of 5. Now we're going to multiply again. 2 minus square root of 5, that's not square root, times negative 13 minus 5 square roots of 5. Is negative 1 plus 3 square roots of 5. And again, we add straight down. 7 plus negative 1 is 6. Plus 3 square roots of 5. And lastly, we're going to multiply one more time. Which doesn't need to give us negative 3. We do get a 0. Questions on this here? Now it seems odd to try to do this and then put variables back to it. But at this point, we're not going to put any variables with this. Because according to our irrational roots theorem, if a plus the square root of b is a solution, then a minus the square root of b is a solution. If we have one, we have to have the other. And what that means for us here is that since 2 minus the square root of 5 is a solution, since it's a factor, it means that 2 plus the square root of 5 has to be a factor also. And that also means that this number down here is also going to have to be 0. Now we'll start off the same way the first one did. We're going to do 2 times 2 plus the square root of 5. Well, that's going to be 4 plus 2 square root of 5. This one's a little bit nicer to calculate. 4 plus 1, because our 1 and 4 are both positive, we're adding together. That would give us 5, yes? What's negative 2 square root of 5 plus 2 square root of 5? 0, so that should just 5. We'll do it again. We'll multiply 5 by our 2 plus the square root of 5. 2 times 5 is 10. 5 times square root of 5 is 5 square roots of 13 plus 10 is -3. Or negative 5 square roots of 5 plus 5 square roots of 5 is 0. And lastly, we're going to multiply through by -3. So -3 times our 2 plus the square root of 5 is going to be -6 minus 3 square roots of 5. Which that whole thing does indeed become 0. So would we say this is very different from what we were doing with the other synthetic division? No, I mean the terms get a little bit uglier, but luckily the 30xs, just some calculations will simplify it out. The middle step gets a little weird, but then after we do its conjugate, we get to something nice. Now to finish this out, to find the other factors, we can plug the variables back in, telling us that we're left with 2x squared plus 5x minus 3. Since the third term is negative, our signs are opposite. Factors of x squared are x and x, 2 and 1. There's a good chance I'm going to have to switch the signs. 1 and 3. 2x times -3 would be -6x. 1 times x is positive x, giving us -5x. So yes. Switch them. So those are our last two factors. Does this make sense on how this is working? Now our other two factors are going to be these here. Now the way we get these, it's all we did, or all we had to do, is take x equals 2 minus the square root of 5. Subtract 2 from both sides. Add the square root of 5. Knowing it's x minus 2 plus the square root of 5 is equal to 0. We're just moving everything back to the same side. That's our factor. Really, we just flipped the signs and got it on the same side. Does that make sense? But that's how we go about this here. And I do find it very interesting that synthetic division works this well with our irrational solutions. Because the other way we'd have to do this is with these two, is we would have to actually multiply them together to get the quadratic, and then do long division or divide it by that polynomial. So it's kind of nice that this works the way it does. Because even with these irrational terms, we could have imaginary terms. X to the fourth. Let's say x to the fourth plus 1 divided by, or we're dividing this or saying that one of its factors is I. So if I set this up, you don't have this on your paper. 1 for x to the fourth, 0 for x cubed, 0 for x squared, 0 for x and 1. And we have I. Well, 1 times I is I. 0 plus I is I. Now our I times I is I squared, but I squared is just negative 1. So 0 plus negative 1 is negative 1. I times negative 1 would be negative I. 0 plus negative I is negative I. Sure, yep. Well, that'll give us 1, 2. So that doesn't. There's negative 1, negative 1. Negative I squared is positive 1. Yep. Yeah. X to the fourth. X cubed. X squared x 1. Yeah. Should give us 0. Unless I am. It's negative I squared, negative, negative. Negative I squared is 1, 1. Negative I, negative I. It's the same spot. Interesting. But it does work with these I terms. I'm trying to think why it's. Let me. Yeah. Because that should work. Or if we just stuck with I, let's go back to the normal one. I. 0 plus I is I. I times I is I squared. I squared is negative 1. I times negative I. Negative I. Negative I squared. That'd be negative negative 1, which is 1. All right, yeah. I don't know what's up with that, but that's it.